Okay, Talal, you had a question? Phosphorus cycle? Okay. Phosphorus cycle. You guys gonna be sick of this, and I've done it in every single tutorial. Okay? So, phosphorus cycle. Where do we naturally find it? It naturally occurs in the lithosphere. And lithosphere includes soil, rock, sediment. Okay. You could say soil, rock is fine. So, I just realized this is going to be backwards, but that's okay, so I'm talking through it. So, the lithosphere. How do we naturally get phosphorus out of the lithosphere? Naturally.
Naturally, whether
uplift.
We're going to get it through uplift and then weathering. So this means it is what kind of process? Fast or slow?
Slow.
It's a very slow process. This slow process prevents what? No. It prevents too much phosphorus being released, which prevents overgrowth of algae.
Oh, yeah.
Okay. Natural process keeps that cycle bound up quite nicely. When humans get involved, what do we do?
extraction.
Mine.
We're going to mine it. We're going to extract it. Either of those is appropriate. Okay. What do we use it for?
Soaps. Fertilizer.
Soaps, detergent. Keep this in your back pocket for later. Pesticides. But the big one is fertilizer. Okay? And the fertilizer is in what format? NPK. What does NPK stand for? Fantastic. Do humans just go out and be like, hey, this spot needs some fertilizer? We go out to the field and go, we're Oprah. Fertilizer for everybody. Okay? So we overuse fertilizer. And that fertilizer is going to do what? It's going to run off. It's going to enter a water source. Then what? It causes an algae bloom specifically. Give it a name. What kind? Cultural eutrophication. It is cultural because humans cause it. Is eutrophication a natural process?
Yes.
Yes. Okay. What happens when you have an algae bloom? They use up all the dissolved oxygen. And that's going to lead to dead zone or if it is asking for long-term impacts. Immediate impacts, this is your go-to answer. Okay? All right.
It's not in the atmosphere.
It does not have an atmospheric component that is a what? There's no gas form. What form might it take? Aerosols. And aerosols are just water droplets with phosphorus. Okay? So let's connect this to something else. Why is phosphorus something that is so important? It is a limiting factor. A limiting factor is what?
Limited.
Vital to life.
Why is it vital to life?
Enhances plant growth.
How does it enhance plant growth? Because it is required for, and I'm hearing it,
ATP.
it's required for ATP, which is the major energy source in the body,
DNA.
and it is used for DNA and RNA. Okay. If you're asked about the phosphorus cycle, there's what you need to know. Okay. Anybody wants to take a picture of this, now would be the time. Yes, Cody.
Is it gonna be like we gotta name all the sub parts too? Like the 1, 2, 3, 4, the 1, 2.
You guys want me to?
Like the soaps, detergent, pesticides, that part?
Yes, and the ATP.
You should know that. You should know that that's what it's used for. All right. What else? Yes, sir. Say that one more time.
Can you like go over like one of the problems they said not to actually
Gotcha. That seems to be like the thing that's getting you guys. This one in the primary productivity. Okay, so we define primary productivity as what? Primary productivity equals the rate of photosynthesis measured as?
Photosynthesis.
Okay, you can call that biomass. That's fine. Over time. Okay, so the rate of photosynthesis over time in a given area. Okay. Why do we call it primary productivity? Primary producers are doing it. Okay. So in this case, we're talking about photosynthetic organisms. Okay. That should be self-explanatory, but let's label it. Okay. So when we're thinking about primary productivity and we're looking at ecosystems, there are two ways that we address primary productivity. What are they? Net primary productivity and gross primary productivity. Okay. Gross primary productivity means what? That's everything. Okay. So this is the total amount of photosynthesis and all of those processes that happen in a particular area. Okay. What is the formula to calculate gross primary productivity?
NPP plus CR.
NPP plus cellular respiration. It's the total. Okay. NPP, how do we get the formula for that? Equals GPP minus cellular respiration. So algebraically, how did we get from one to the other?
You add or
Isolate the variable.
Okay, so we want to isolate NPP. How do we do that?
CR over
How do you move it over?
minus CR.
You're going to subtract cellular respiration from both sides. Okay? So if you were given this on the test or being asked to solve a problem on the test, you would be given two of those factors. Okay? You would never have to calculate them straight out. All right? So let's say that we have ecosystem A, ecosystem B, and ecosystem C. Okay? Ecosystem A has an NPP of 1,492 kilocalories. Okay? That's how you'll see that measure. Okay? And it has a GPP of 2,989 kilocalories. You would be asked, what is its rate of cellular respiration? How would you solve it? Okay, so make sure when you're doing this that you're actually like putting the formula. Okay, if it can be solved through that dimensional analysis factor label method, solve it that way. If it cannot be, it's a formula, put the formula. Okay, so we know NPP, we know GPP, we want to figure out cellular respiration. How might we manipulate our formula here?
starting from which one?
Pick one.
You use the SPP one. If you use the GPP one, you would just subtract NPP from both sides.
Okay. So we could do it like this. Is that how we would do it?
Plus.
Yes, we would. Okay? And then just solve. This is pure algebra problems. Okay? Let's say that B has an NPP of 964 kilocalories with a GPP of 2,989. Which of these ecosystems, A or B, is going through more cellular respiration?
D.
B. Why? Its NPP is lower. Those are the primary productivity problems that you'll be asked about. Okay. Calculators will not be provided for you. You need to bring your own calculator. Legit, one of these, like a small one, that will do simple addition, multiplication, division, subtraction. Thank you. Will suffice. Okay. If you don't have a calculator, all of these problems can be solved using pencil and paper. Okay. Yes, sir. Dimensional analysis. You guys did that in chemistry. You called it stoichiometry. Okay.
Oh,
That thing. Okay. So, for example, you may be asked, how many feet are in 9 kilometers, for example. Okay? These are simple conversion problems. All you would have to do first is figure out all the conversions that you know. Okay? So, you need to brush up on your metric system. You need to brush up on it. So you remember this, right? What is the acronym? Okay. So kilo. Thank you. Deca. There's your base. C. Centi. Milli. And I know there's 2 L's, but I'm too lazy to write. Okay? So make sure that you know these. Okay? This is a base 1. Deca is how many?
10.
It's 10 times greater. Heck,
100.
kilo.
1,000.
Deci.
1.1.
Centi.
0.01. 0.001.
There you go. Yes, sir.
How does that help with the heat?
What?
How does that help? 2.54 centimeters.
Ah.
Kilo.
So the only actual conversion outside of the metric system that you need to know is that 1 inch is equal to how many centimeters? 2.54 centimeters. You can do 2.5. That's cool with me. If I calculate it, I will always calculate it both ways. All right. So now, what would you do?
Convert kilometers to centimeters. Centimeters to inches.
Or you can do feet into inches. You don't
Is there a wrong way to do it in terms of order? No wrong way. My personal preference is to get that unit that you need at the very end. Okay? So, for example, we have 9 kilometers. Okay? We want to get rid of this kilometers. We're going to turn it into meters. Okay? Get rid of that. How can we get rid of meters? There's 100 centimeters in 1 meter. Now what do we do? 1 inch. Okay? How do we get rid of that inches? Multiply across the top, multiply across the bottom, and divide. That's the kind of thing that you would do. Okay? You're just looking to get rid of all of those units. Okay? If you're one of those people that's like, I can't stand that blank spot there, 9/1 is the exact same thing. Okay? So that's the kind of problem you do. Yes, sir. Yes. The first and second laws of thermodynamics. Once again, make sure you remember your metric system. Thermodynamics is what? Thank you, Nathan. We're trying to break it down in your Greek and Latin. Thermodynamics. It means process of. Dynamos means movement. Thermo means heat. So this is the process of moving heat. In this case, when we talk about heat, we're talking about what? Energy. Okay? There are two laws of thermodynamics. You know them, you just might not have seen them called that way. Okay? The first law says energy cannot be created or destroyed.
Oh, that's great.
It just does what?
Moves.
Shifts phase.
It can change form. Okay? So we can go from chemical energy to kinetic energy to electrical energy to potential energy. Okay? What is this actually describing? Law of conservation of energy. Okay? Meaning, again, I just use E negative for energy. Bear with me. Because it makes sense in my head. So it's conservation of energy. Whatever energy we start with, we're going to end with. What's the second law?
It moves away.
It flows away from high.
No energy conversion is 100% efficient. What do I mean by that? What do we mean when we say lose energy? Okay. It's going to turn into something that is unusable. In this case, we mean heat. Okay. You may also see it referred to as low quality energy. Same difference. Okay. So if we're talking about thermodynamics and no energy conversion is 100% efficient, what is the thing you should remember? It's the 10% rule. Okay. And the 10% rule says in energy conversions in a trophic system, what happens? You lose 90% every step you go, or you convert 10% every time you go. Okay? That's what you should be able to discuss for thermodynamics. What else? You won't need to know benthic zone at all.
Do we need to know any biomes?
Yes, you should know some biomes.
I mean, like which biome?
Which biomes do you think you should know?
Oh, yes.
You should know all of them. And I'm going to refer you to the first video that I did because that's the first thing I did was aquatic biomes and terrestrial biomes. What else? Kobe. You should know major characteristics in terms of temperature, precipitation, and precipitation, yep. And then relative location. So you should be able to be like, okay, well, tropical rainforest is going to be on the equator. Tundra is going to be far away from the equator or very high up. What else? Hydrologic cycle, show me. Show me. So Somebody remind me before you leave that I need to flip this video.
You know what?
Flip it so that the text is in the right direction. Okay, so hydrologic cycle. Why is the hydrologic cycle so important?
It's the water cycle.
It is the water cycle.
Everything needs water.
Water.
Everything needs water to live. Also, all of the other cycles are influenced by it. Okay?
Runoff.
So, where do you want to start? We're going to start in the ocean. Okay. There we go. Okay, so we're going to start in the ocean. What are we doing in the ocean? Water is evaporating. It evaporates, it moves up into the atmosphere. The further it goes, the colder it gets, so it does what? It condenses. Okay. In condensation, it is connecting with the sulfur cycle. The sulfur cycle allows it to form droplets. Condensation forms clouds. And depending on the temperature of those clouds, you either get rain or snow. Okay, you don't have to go that far. Okay, what happens next? Okay, so we can get precipitation here. Okay, or this can move over here, and we get precipitation here. Okay, what's next?
Runoff.
Okay, we can do transpiration, or what else this might be called? Sometimes you'll see it called as evapotranspiration. Okay, transpiration is fine. Okay, so we have this precipitation. I've heard it said like 3 times. It goes through runoff. Okay, it can go into bodies of water, can go into rivers, lakes, streams, into the ocean. If it is able to, it's going to infiltrate. And eventually, if it's allowed to, it's going to end up in an aquifer. Okay? If it stays in the soil, we're talking about like our water table. Okay? Those are the components that you should be familiar with. Okay? Here is my question. What is going to impact infiltration the most? Non-porous or non-permeable surfaces?
Concrete.
What's the first thing you
Non-porous, meaning there's no holes in it. Okay? So non-porous or impermeable surfaces are going to prevent that infiltration. Okay? Prevention of infiltration is going to increase what? Runoff. And if you're running off things like a parking lot, what happens? You may get trash. You may get gasoline dripping, oil dripping, all those kind of things that stay on asphalt. Okay? How do we impact the formation of aquifers?
It stops it from going back.
Okay, well, yeah. I mean, how do we get to the aquifer and be like, nope, no more aquifer?
Well, drain off the water.
We drill it. We put a well in there. And we use it for mostly irrigation. Because this kind of water is what kind of water? Groundwater. Groundwater is exclusively fresh water. Okay? So we drill into it. We get fresh water that we can use for irrigation. We can use it for drinking water. Okay? Aquifers take a long time to refill or recharge, right? If we're using these non-porous or impermeable surfaces, we're reducing our infiltration, therefore reducing the formation of our aquifers. And we're running out of available fresh water. Yes, sir. Okay.
For like floods and like run the water across concrete. What help if it was like dirt?
Yes. So a lot of places, especially if you go down to like if you go out to like Nag's Head and the Outer Banks and things like that, their parking lots aren't regular parking lots. So they have these kind of diamond-shaped bricks. And inside the bricks, there's sand and soil. So there's a little bit of a hard surface for your car to sit on, but there's plenty of space for that water to actually infiltrate it. Okay? Second question.
Same question. Can all plants use like salt water for growth or just
There are some plants that can do that. We'll talk about that a little bit more when we get into agriculture. But there are some plants that have been bioengineered or used for genetic modification, where they can withstand higher salt content in their water in order to grow. So we can use salt water as irrigation. But the general answer to that is if it's on land, typically it's a freshwater plant, unless it's been bioengineered any other way. Okay.
Does the temperature of water mess with how much it grows?
I do not know the answer to that question. So that might be something that we need to look up. Somebody who has their laptops, do me a favor. Google, does the temperature of water impact how plants grow? Like irrigation, temperature of irrigation water. Okay, hold on a second. What?
Mainly, if it says that if it's mainly like high external temperatures.
Okay.
So like the higher the temperature, of course, that's what they're doing.
Okay, so extreme temperature of water is not going to help.
Yeah.
But not necessarily cold water is going to help either.
Not going to use our amazing
Just hot water. Okay. Yes, sir. Where's the water going to come from? Where are we going to get another water source to get the water from? Oh, yeah, we're going to go to Mars and bring water back. Yeah, that's exactly what we're going to do. They tried that in Doctor Who. It didn't work very well. Absolutely. Jazzy is describing a way that we can produce fresh water from salt water. It's called desalinization. Okay. So we take salt water, we run it through a process. Typically, it's what we call reverse osmosis. So, osmosis is just the movement of molecules from high concentration to low concentration. Reverse osmosis is we're forcing it to go the other way. So we force the water through a membrane that prevents the salt from going through, but will take the water. Okay. We use that water as fresh water, but we have a lot of salt water left. It's called brine. That brine is either one, sold to be used as like table salt, or it's pumped back into the local water supply, the local ocean, which is going to immediately increase your salinity near the coast, which is going to cause a lot of problems for your ecosystems there. Plus, desalinization is incredibly energy intensive, and it is incredibly contributory to pollution because of the energy that it uses. Yes?
Is there like a reason that the salt concentration why different parts of the ocean have color water?
What do you mean different color waters?
Like I've seen
like coasts are nice and turquoise.
That Atlantic, like the Atlantic is like a brown.
It's all about refraction and what's in the water. That's physics. Don't ask me about that, bro. I didn't do too well in physics. Next question. You got 10 more minutes. Symbiosis.
symbiotic.
Symbiosis.
That's a new one.
Symbiosis. All right. We're going to talk about the symbionts. As long as we don't have to talk about carnage. All right, symbiosis. It is an example of a what? Between? It is an organism interaction. By explicit definition, symbiosis is just what?
An interaction, right?
In an ecosystem.
Any sort of interaction with close proximity.
It is a long-term interaction between two organisms in close proximity. The AP exam uses symbiosis as what?
They say mutualism.
On the AP exam, if you see symbiosis by itself as an answer, they are typically referring to mutualism. Okay? Don't ask me why they do that. They just do. Okay? So let's talk about the different kinds of organism interactions. Give me one. Competition. Starting with the big boy. Okay? Competition is what kind of interaction?
Negative.
Negative, negative. Why is it negative, negative?
Resource.
Both are going to lose resources or something in this process. Yes, sir.
At the end, won't one like gain the resource?
Potentially.
Only maybe. If it's strong.
It is potential that one organism could get the resource, but it's still going to expend more energy in the long run than it would if it was in its own niche and didn't have to compete. Okay? Tell me more about competition. Inter and intra-specific. Inter is inter. Different species. Intra. There we go. Okay. Competition is going to lead us to two different ideas. Resource partitioning and
the one that like
so we're looking at resource partitioning or competitive exclusion. Okay. So in resource partitioning, what are they going to do? They're going to split the resources. How do they know to split the resources?
because otherwise you're gonna be both killed.
Do they come up to each other and go, well, I'm going to eat here, and you're going to eat here. I'm going to come out during the day. You're going to come out at night.
No, it's just sort of what's happening.
How do we get this?
Different species.
Magic.
Coevolution is going to lead to that. We'll talk about that in the next unit. Okay? Competitive exclusion means what?
One dies.
One organism is either going to die or going to get pushed out of the ecosystem and have to go somewhere else. Okay? What's another one? What? I heard predation. Predation is a what kind of interaction? It is a positive minus. Who's the positive?
The predator.
Who's the negative?
Prey.
Does the prey develop methods to get away from the predator?
Yes.
Does the predator develop new methods to get their prey?
Yes.
It's the arms race. The arms race is an example of what? Evolution. Okay? Yes, sir.
Is there ever like instantly competition within some series that won't see like sleep?
Yes. Yes, that happens a lot. No, the dodo birds just don't. We'll talk about dodo birds just don't.
Yay.
Next, what's another one? Commensalism.
One doesn't care.
One is benefited, the other one could care less.
It's the cows, they eat them, they step on the grass, and it's like birds eat this.
Cows walk through grass, kick up insects, birds follow behind, the cow could care less. Bird now has food. What's another one?
The one that is harmed and the other one is neutral.
Okay, well, you're walking to amensalism, not necessarily tested, but a good one to remember. turns into a good example. One of them is harmed, the other one doesn't care.
Animal gets hit by a car.
You could do that one, or we can go back to the cow. The cow's walking through the grass. Is every insect getting kicked up?
No.
Some of them are getting stepped on. The insect is like, well, I'm dead. The cow, on cur. Yes, sir. Parasitism. Parasitism is plus minus. Who benefits? Who's harmed? Parasite. Does it have to be living inside the organism to be a parasite?
No.
No, it can live on or in. Is the parasite usually smaller than its host?
Yeah.
Does the parasite kill its host?
Not usually.
Not usually. What's the benefit to the parasite of killing its host?
You don't count food.
There's not one. Okay?
It's fun.
And we're missing one more. Mutualism. And mutualism is plus plus. They both benefit from this interaction. Yes.
One of them sort of like when a person like killed a bug.
Yeah. Yes. Yes.
Would a parasitic one be like humans and mosquitoes?
Yes. Yes. They live on us for a short period of time. Yes. Or is it? Oh, that's true. Okay. All right. You got about 1 more minute for the last question or topic. Yes, sir. It's not considered mutualistic. It's part of a competition. It is a competitive interaction. Yes. Coevolution is when two organisms evolve together, either to live in the same place beneficially or as in predator-prey. The prey develops the ability to run faster, so the predator develops the ability to run faster. And it's back and forth, the two of them trying to outdo each other. Okay? Yes, sir. I looked that up. The mosquito that carries malaria is parasitic. Malaria itself is just a disease. All right.